Now the statement 2 less than x and x less than 9. How can we represent that property of x on the number line? Okay, well, 2 less than x. Let's locate 2 on the number line. Now, for what x values, x is some value along the number line, where would x have to be on the number line in order for 2 to be less than x? Well, clearly, x would have to be to the right of 2. Then 2 would be less than x. So, x is greater than 2 for every point, not including 2, but every point to the right of 2. And where's x less than 9? Well, here's 9. X less than 9 means that x is to the left of 9, which means that x is going to be on this side of 9. Again, not including 9. Now, it's not real clear that I had an open circle around 9, but I did. It's just a little hard to see. So x less than 9 from here to here, well, from here all the way to left. And then 2 less than x and x less than 9, okay? Now, let's think about this logically. Okay, if I'm here, is 2 less than x? No, it isn't. So we certainly can't say that 2 is less than x and x is less than 9. What about here, between these 2 points? Well, yeah, anywhere between these 2 points, 2 is to the left and 9 is to the right. So any point between here and here satisfies this condition. So that's the region that I indicate. And just to be sure, let's check out here past 9. Well, 2 is certainly less than x if we're out here, but x is not less than 9 if we're out here. So the region for 2 less than x less than 9, or 2 is less than x and x is less than 9, lies between here and here, and that region can be described as, in terms of the inequality, 2 less than x less than 9. Okay, another question. X is within 5 units of 2. Okay, where are some points where that's true and where are some points where it's false? Well, somebody said 3. Okay, yeah, 3 is only 1 unit from 2, so it's within 5 units of 2. And then, okay, well, 5, yeah, 5 is within, actually that's 6. 5 is here. 5 is within 3 units of 2. So any number up to, and possibly including 7, depending on how you interpret the word within, which is not really a mathematical term, is going to be within 5 units. So all these points are within 5 units of 2. Now, there are also points on the other side. We can go 5 units on the other side. We could go -3, -4, -5, -6. That's not -4. Okay, here's 2, 1, 0, -1, -2, and we need to go to -3. I apparently didn't read carefully enough, didn't look at my graph carefully enough, and should have included -3 here. So we got -3 here, and we have 7 here. Now we can say then that -3 is less than x is less than 2. This describes the property that x is within 5 units of 2. That's an important idea. Okay. Now also the property x lies more than 5 units from 2. I'm going to pause and write something here. Okay, just wrote down the condition that x lies more than 5 units from 2. We were running short at the end of class, and I didn't have time to write that down, but everybody, I think, knew what we were talking about. Well, again, we have 7 out here, which is 5 units from 2, and we have -3, which is also 5 units from 2. More than 5 units from 2 would not include 7, but would include every number to the right, because everything beyond here is more than 5 units away from 2. 5 units from 2 is this far. Okay? Or on this side, 5 units from 2 is here. More than 5 units from 2 is to the left of this. Now, we could express that by an inequality, but the question was just to graph it. But I'll go ahead and write the inequality here, just a little extra. We can say that x is greater than 7, or x is less than negative 3. Now we put or in here because x could be this or this. It can't be both. So if we put and here, we would have to have x greater than 7 and also less than negative 3. So and doesn't work. The expression here then would be x lies more than 5 units from 2, could be translated as x greater than 7 or x less than negative 3. Now, we're also going to see before too long how to express this interval in terms of an absolute value inequality. But as far as just doing it in terms of regular inequalities, in this case we need two inequalities connected with an or. Up here we actually have two inequalities connected with an and. Negative 3 is less than x and x is less than 2, and we combine those two and inequalities into a single expression.